Welcome to the second Torso and Shoulders lecture in the Digital Figure Sculpture course. This week we're going to talk about something that I consider very important for understanding the shoulder region, especially as we work our way out to the arms from the thorax. And it's something that is called the scapulohumeral rhythm. And people who have been on the anatomy course, we talked about this briefly. And essentially what it is, to remind everybody and to introduce it to people who are new, is it's the relationship between the rotation of the humerus in a socket, so the upper arm, and the rotation of the scapula on the back. Okay, so just have a quick look at this as it goes through the motion. So at default, we can see the spine of the scapula here, and as he raises his arms, the scapulohumeral rhythm more or less dictates the change in angle of the medial border of the scapula versus the elevation of the humerus. Okay, so we'll talk about that relationship, and you guys will get a chance to investigate the forms of this week in your sculpting exercises. And we're also going to go around to the front of the body and talk about scapulohumeral rhythm in relationship to the clavicle, because the clavicle has a critical part to play in this in the rotation of the scapula, and it's all via this juncture at the acromion process and the distal end of the clavicle. Okay, so we'll quickly talk about some of the anatomy involved in this, just to give you guys an orientation to the things that are important as far as landmarks go. So first, the whole thing that controls this is the glenohumeral joint, right? So where the ball and socket joint, where the humerus pops in here, right? So when we talk about the scapulohumeral rhythm, we're talking about rotation of the humerus in a socket out to the side, and then the corresponding rotation of the scapula. So that first rotation takes place in the glenohumeral joint. Okay. From there, the second effect of this is in the acromioclavicular joint. And this is actually a fibrous joint at the junction of the end of the clavicle and the acromion process. Right? So when I kind of box this in, this is going to be a really important area for us as we get to sculpt it. Right, and I'll show you a couple more views of this, and as we get into the working example for this week, you'll see me looking at this area quite frequently as I work the models through the different ranges of motion. Okay, so acromioclavicular joint, have ligament holding those two together, and so it's not a free joint like a ball and socket, but a fibrous joint. So there's little flexion, but for the most part, it's fairly structural and rigid. So it'll give a few degrees of motion, but not much. From there, we'll talk about, we'll move in along the clavicle, and we'll talk about the sternoclavicular joint. And we're going to have some good stuff happen here, and we'll see that as people elevate their arms. A lot of things expected and unexpected happen here. And as I explain this, hopefully it'll be a little bit of an epiphany for some of you who've sculpted and drawn raised arms before, because there's a lot of interesting things that happen in this joint as the arm goes up. And the final joint is not a proper bone-to-bone joint, but it's the joint, so-called joint of the scapula sliding on the thorax in the back, and we call that the scapulothoracic joint. And that is essentially the free rotation and travel of the scapula over the rib cage. Because there's no actual bone-to-bone attachment there. Nothing bound with ligaments. It's just muscle pulling this across the rib cage. Okay, so those are the big players in this. Let me just erase this pen. One more thing that's going to be important for us to understand is kind of that this whole structure between the clavicle and the scapula is bound together by ligaments. Right, so remember this little thumb down here is the coracoid process. And so we actually have ligaments, which are non-flexible straps tying the coracoid process to the clavicle, and also the coracoid process to the acromion. Right, so this is all pretty well bound together. And then remember this ligament as well. So this section is pretty tight. So just know that things can rotate around there a little bit, but you have these kind of inflexible fibers binding it together that are going to put a stop to too much flexion between scapula to clavicle. Okay, enough of that. Let's look at this really quick in dissection. Again, turn your head away if you're squeamish. Sorry to not forewarn you, but we're here. So this is what I want you guys to memorize as far as shapes go for bony landmarks for the scapula, acromion right here, spine of the scapula going down here, and the distal end of the clavicle. Look at this little ligament going here. And then actually you can see the other ligaments that I've just talked about going down to the coracoid process. So remember this gesture, this round S shape coming out to here. This stops. I'll just change colors really quick. Clavicle stops, joins on to this rectangular shape of the acromion. Right? You'll see me in this week's working example just really being deliberate about defining this shape on the shoulder of the model that I'm working on, because it's very important, because as we know, it gives rise to all of the deltoid. Well, it gives rise to this middle head of the deltoid and trapezius above, and then of course the clavicle has origins and insertions for the trapezius and the front deltoid going down here. Right, so really these are the landmarks that we need to attend to. And this is going to be what we're manipulating when we're working through this exercise of the articulation of the shoulder. Okay, just a quick view of, sorry, move back. Just a quick view of the clavicle joint, and to kind of refresh the anatomy on here. So this is the clavicle sitting against the manubrium with the muscles kind of cut away on the right side. On the left-hand side, it's all intact, so we can kind of see clavicle here. This is the clavicular section of the pectoralis major. Again, look at where this originates from. It originates from more or less the top margin of the clavicle, right? So it's kind of important to us, and it'll be a little bit more important when you guys understand how the clavicle articulates. Okay, then move down past the joint, you get the first sternal section of the pectoralis major, and division at the manubrium, and so forth and so forth. Okay, just a quick view of this to get you guys thinking about the clavicle and how it interacts with the manubrium. Okay, so now let's just talk about the actual scapulohumeral rhythm. So pretty much, to summarize, what it says is when the arms are at default, we'll consider this 0 degrees of adduction. So when the arm goes out to the side, this is adduction. My beautiful script. So 0 degrees of adduction will give you kind of the neutral pose for the scapula, which should be more or less vertical. These things are variable from person to person, so there's always, like everything in anatomy, there is a bell curve and a distribution of how accurate this generalization is that I'm giving you. But I try to hit the middle point of the bell curve and maybe a standard deviation either side. Okay, so more or less vertical is what we'll say. Okay, and then as you move your arm out to the side, the observation that people have noticed is that for the first 30 degrees, it's called the fixing phase of the scapulohumeral rhythm. So nothing really happens. So essentially the muscles are fixing, coming to kind of a stasis against each other. So all the things that work in this area, teres major, rhomboids, infraspinatus, supraspinatus, teres minor, etc. Okay, so the first 30 degrees is free. We don't expect anything to happen to this border. From 30 degrees up to 180 degrees, which is pretty much all the way overhead, there is a 2-to-1 relationship between the adduction of the arm and the rotation of the medial border of the scapula. Okay, so let's just work through this. So this is 45 degrees. We'll consider this, well, we'll look at this guy and I'll tell you what should happen. So consider it 30 degrees. If it was 30 degrees, this would still be vertical. And on the right side, it more or less is. And you'll see asymmetry in this guy. On this side, it's actually started to deviate a good bit. So he has quite a bit of asymmetry between these two sides. But more or less, the right-hand side follows closer to what we expect. So the first 30 degrees are free, and then beyond that, it's a 2-to-1 relationship. So if we're at 45 degrees, we can calculate this rotation by subtracting 30 degrees, so the free portion. And that will give us 15 degrees of adduction in the arm that is accounted for by pretty much half in the scapula. So half 15, and it should be 7.5 degrees of rotation that have occurred here. And maybe it has. 7.5 is not appreciable. This side is a bit of a statistical outlier because he's already at something like almost 20 to 30 degrees. Okay, so very interesting that this moves at a different rhythm than the right side, possibly a former injury or something. Okay, this is actually why they have the scapulohumeral rhythm. It's a clinical tool for analyzing people's shoulders and the function or dysfunction of them. Okay, so now at 90 degrees, we'll do the same mathematics that we just did. So the first 30 degrees are free. So we'll subtract off the 30 degrees, and we're left with 60 degrees of elevation that happened in the arm. So if we're talking about the humeral adduction, remember we had the first 30 degrees from vertical. Right here, we're free. And we're just looking at this next 60 degrees. Okay, and the 2-to-1 relationship between humerus and scapular border, rotation of the scapular border, says that there should be 30 degrees. So we'll divide that by 2, and that gives us 30 degrees of rotation in the scapula. And that's about right there. Okay, so this side again is pretty nice. This side is quite a bit further along than that already. He is probably, I'm looking at this little junction to define the end of the spine of the scapula. Acromion sits out here. And I'm looking at the end of the teres major coming down here to define the inferior border of the scapula. So he's already on this side probably at 45 degrees. Okay, so let's just move forward. We'll say this is 135 degrees. I'll spare you guys all the details, but from 90 to 135, it's moved another 45 degrees, and if you have 45 degrees, what is that? It's another 20-ish degrees. So not quite far enough here, but this is probably also not quite 135 degrees. 135 degrees would be right here. This is probably 120. Okay, but this side again is ahead of pace, and we continue up all the way to vertical, and we can see that this one is almost 90 degrees. He's probably 80 degrees. And this guy is probably 60, 50. Okay, and just a quick calculation on what it should be using the ratios that we're talking about. So 180 minus 30 gives us 150. And then if we half 150, that should give us 75 degrees of rotation in the scapula, right? So probably this is what we would expect on this side based on this formula. That's kind of convention. But again, it's convention and it hits that middle point of the bell curve, right? So there's a lot of variability in when the rotations start and when they kind of slow down. It's like animation curves almost, easing in and easing out. And it's quite variable from person to person. So just be aware of that. But if you're constructing, use it as a rule for placing these angles, right? Because that's what you want when you're constructing, is you want rules of thumb. And then from there, you can observe life and put those small idiosyncrasies back in to make people unique. Okay, so that's all I'm going to say on this for right now. We'll see more of the forms, and I'll talk about the effect all these rotations have on the muscles when we get into the working example. But right now, I wanted to move to the clavicle, right? Because as you probably are aware just from general observation, the clavicle elevates when you raise your arm. Okay, and this is some of this data that I have in this lecture is from really old research paper on the biomechanics of the shoulder. Okay, and they've actually done quite a nice job of summarizing and plotting the data that's relevant to us as artists. Okay, so really what we have here is a graph of elevation of the arm versus the angle of the clavicle. Okay, so elevation of the arm, if it's at pretty much no degrees down here, the clavicle, they're measuring against vertical, is just a little bit more than 90 degrees, so 95 degrees. Okay, and then it kind of goes up more or less linearly, meaning at a fixed ratio as you get all the way overhead, which would be 180 degrees out here. Okay, so rather than talk about changes as degrees of elevation, it's useful probably just to map certain intermediate points, like 45 degrees of elevation, 90 degrees of elevation, 135, and then 180, and just see what we should expect at those, just to help us plan rules of thumb, right? So probably at about 45 degrees, we're looking at slightly more than 100, right? So it's probably at 45 degrees, it's raised about 5 degrees of elevation from default. Okay, if it started at 95 and it's gone up to 100. At 90 degrees, so arm straight out to the side, we're looking at 110 degrees. So we're looking at 15 degrees of elevation in the clavicle when the arm is held straight out to the side. And that's more or less what we're seeing in this illustration here. 135, so we're going pretty much out to the side. 135 again is 45 degrees past horizontal. And that looks like it almost maxes out there, and then it stays constant from there. So that's looking at about 120. So 25 degrees would be the maximum elevation above horizontal that you would get. And any further elevation in the arm is not doing anything to the elevation of the clavicle, right? So from 135 degrees to arm directly overhead, clavicle's not getting any higher than 25 degrees. Okay, that is good to know. So almost going in almost in 10-degree steps between these 45-degree increments. So as we go 45 degrees further along, we go from 5 to 15 to 25, and then we're constant. Okay, so put those in your mind for rules of thumb when you're constructing this, or if you're doing drawings, or just observing in a life drawing session. Just pay attention to this. The next thing I'm going to talk about is a complexity that nobody has probably appreciated. I certainly didn't appreciate it, but I'm aware of it. And that's the fact that as you raise your arm out to the side, not only is your clavicle elevating, right, rotating this way, it's also rotating axially, so along its long axis, right? So it's rotating backwards on itself, right? It's rotating towards the chin, if you will. Okay, and this is a crazy effect, but really what it allows you to do is it allows you to get that last bit of elevation in your arm, because we saw all those ligaments holding the clavicle to the acromion, and the acromion to the coracoid process, etc. If we didn't rotate the clavicle, all those ligaments would be bound too tightly to allow the arm to go any higher than about 120 degrees. Okay, so really what this graph says is the clavicle is not rotating on itself at all until probably about 60 degrees, but we can almost say, well, from 60 degrees to 180 degrees, it's almost going in a linear fashion, but actually it accelerates a little bit as you go higher and higher with your arm out to the side. And while you guys are sitting there, I want you to do this test for me. Take your finger and place it on the head of your clavicle, right near the pit of your throat. Kind of find the upper bony prominence on your clavicle, the head of your clavicle. And then just raise your arm out to the side. And as it goes overhead, past 90 degrees, you should start to feel it rotate out from under your finger, and then come back as you lower your hand down. And it's crazy, but it gives us a lot of form visually and sculpturally when we look at the effect of this rotation. Okay, so pretty much the thing we need to know is at 60 degrees, it's not rotating. At 180 degrees, it's rotated up to 45, 50 degrees. Right, so it's rotated back on itself, almost a, this is the axial view, this is looking forward. So say this is actually, so we're looking down somebody's arm, and say we actually have some chest muscles, for example, some clavicular origins of the pectoralis major sitting there. As your arm goes past up to 180 degrees, this rotates 50 degrees, right? So this arrow is now rotating up this way. And that means the origin of the muscle is now up here. Right? So this is going to be crazy, and we'll see this on the reference, and we're going to sculpt it this week. Okay? So just a quick aside, how did they measure that? It's beautiful what they could get away with in the old days. People who are on the anatomy course saw the X-ray, the movie and X-ray videos where they blasted people with radiation to get their medical data, their research data. For this one, they drove a metal spike into the head of this guy's clavicle, a small, thin spike into his clavicle, and they just hung a little protractor on it with a weight. And they had him abduct his arm, or adduct his arm out to the side and elevate it to the front, and measured the angles that way with this little metal rod stuck into his clavicle. You can't get away with that anymore. How much science have we missed out on because we can't do these small inconveniences? Anyways, let's see the effect of this kind of rotation. Okay, so primarily what I want you guys to appreciate as I go through these is, on the front view, the chest muscle is kind of flush with what would be the top of the clavicle coming out here. In the back view, the acromion process is quite foreshortened like this, right? And going down here, you can't really see the rectangular shape of the acromion process. Okay, as we step through our different articulations, we should start to see the clavicle elevate. Yes, so we do. Agreed. from 45 to 90, we get 10-degree step like we talked about, so maybe from 5 to 15 degrees. And it's starting to rotate back on itself. So we're starting to see this come up higher, right? We're not making out the top end of the top edge of the clavicle anymore. And also, as the clavicle starts to rotate, it's bound by ligament to the acromion, right? So the acromion starts to rotate backwards as well. So we're starting to see more of the square shape of the acromion as we go higher and higher with the arms. Okay, up again. Look how billowing this is. Look how the front deltoid starts to appear as a big elevation. And in fact, because it's all rotating back on itself, you start to see the acromion here, and you start to see the front deltoid popping out from behind the trapezius, right? Everybody's probably familiar with this visually because we've seen it a lot. Anybody who's done life drawing or studied from reference knows that this is the case, but it's hard to quantify the actual mechanical effect. And then at 180 degrees, we're rotated back fully 45 degrees, 50 degrees in the clavicle, and this is what you get. You get this nice big flush muscle, right? Almost wrapping all the way over. And we get a nice big exposed view of the square of the acromion as a result. Okay, and kind of you can see the S shape of the clavicle is going to be doing this, right? The lip is going to come up, and you can see how the front deltoid is going to be exposed as a result of that rotation. Okay, so crazy. Hopefully very interesting, and you guys are going to get a chance to practice that this week because we're going to do some of these sculpts to kind of really do the same thing. These are a couple examples from 0 to 180 degrees, but the working example has all the angles in between as well. So the job for this week is going to be to work through all these different articulations. Okay, you'll get that in the assignment video though. Good luck, and I will see you in the next lecture.